Question from haloalkanes and haloarenes. Give reason. Although chlorine is an electron withdrawing group, it is ortho-para directing in electrophilic aromatic substitution reactions. So let us look at this. Here's a benzene ring with a chlorine atom attached to it. We are told that chlorine is an electron withdrawing group. Yes, chlorine has lone pairs of electrons around it, but due to its electronegative nature, it withdraws electrons towards itself. Now, withdrawing of electrons is called inductive effect or -I effect. Inductive effect. That is withdrawing electrons. Here we need to consider two things. One is inductive effect, that is electron withdrawing nature of chlorine, and the other is the plus R effect or resonance effect. That is the electron releasing nature or electron donating nature. Now, because of the inductive effect, let us see what happens. Say you have an electrophile like this. Chlorine, here it is withdrawing electrons or taking electrons from the ring, and you have a carbocation like this. There is substitution here, and this has got a destabilizing nature. It destabilizes the intermediate carbocation. Destabilizes means it makes it less reactive. But the plus R effect, on the other hand, it will stabilize the carbocation. And it will stabilize the carbocation or the effect of the resonance effect is more pronounced at the ortho and para positions. Let us have a look at it. Say we have here chlorine is attached. Now this chlorine is donating electrons. This is the plus R effect. So chlorine is donating electrons, and as a result there is the nature of a double bond here. These electrons are coming here, and there's a continuation of the electron cloud, because benzene, as you know, is an electron rich system. And what happens here? When these electrons come in here, these electrons move to this position. So the electron density at that position increases, and chlorine, say we can say it develops a positive charge, and the electron density here is increased. Which position is it? You can see that it is the ortho position. And now this bond or these electrons move in here, and the electron density increases there. So we can see Cl with a positive charge. A bond is formed here. Now negative charge here, or electron density is increasing there. And now this shifts in here and this shifts here. So if you look at the resonance structures, you can see that the electron density is increasing at the ortho and para positions. So this is the ortho position, this is the ortho position. Electron density increasing at those positions and para positions also. So that is happening because of this resonance effect of the chlorine atom. The plus R effect is more pronounced at the ortho and para positions, thus making those positions more prone or vulnerable for electrophilic aromatic substitution, or the substitution reactions take place at that positions. So if we look at the now here we are seeing that chlorine is donating electrons, and as a result at ortho position you have the electrophile substituted, the bonds like this, and at the para position also you will have the electrophile substituted. So plus R effect stabilizes the intermediate carbocation, whereas minus I effect destabilizes the carbocation. Though minus I effect is stronger than plus R effect is more pronounced at ortho and para positions, thus making the substitution, electrophilic aromatic substitution, possible at ortho and para positions. That is why we say chlorine, though electron withdrawing, is ortho para directing in electrophilic aromatic substitution reactions. If we just go through it once more, we have to consider minus I effect or inductive effect, which is electron withdrawing, and plus R effect or resonance effect, which is electron donating effect. Minus I effect is stronger than plus R effect. Then minus I effect destabilizes the carbocation formed during electrophilic aromatic substitution reactions, whereas plus R effect stabilizes the carbocation. Plus R effect tends to oppose minus I effect more at ortho and para positions. So it tends to oppose minus I effect at ortho and para positions and make the destabilization less at ortho and para positions. Thus, electrophilic aromatic substitution takes place at ortho and para positions. Thus, we can say that chlorine, though is electron withdrawing group, it is ortho para directing in electrophilic aromatic substitution reactions.